Hi. So in this webinar, we are going to see some of the issues that you could have while modeling within Graitec Advanced Design. And then we will see how to set elastic support and members, and tension and compression only members as well. So actually, the webinar schedule will be a presentation of the topics of the webinar. Then I will show you all the example I've prepared, and then I will give you some other information, and I will see if there's any question and see if I can answer immediately or if I can answer them later by email. So the first topic is the tolerance. So what is this about, and how we can check our model based on the different kind of tolerances that we have set. And then we are going to set elastic releases and section cut on this model. So the beginning we are going to look at to set type of soil under the foundation, to set an elastic release to model a semi-rigid connection, and also how to check my reinforced slabs, etc., or my area load areas within section cuts to check moments and forces in my slabs. And then we are going to set tension compression only supports and members, and then I will show you some of the issues that you could have with a rigid diaphragm. So the first example is this structure. As you can see, is a sample structure. Can be, for example, a structure that you have imported in from AutoCAD, and in which you have changed the member afterward using maybe a convert line. So in this case, my mesh options are the one by default, and I run my analysis. So once I've run my analysis, everything goes fine. I have my displacement, etc. What can happen is, for example, I've imported it from, as I said, for example, from AutoCAD, and maybe there are some nodes that are not really attached one to each other. So if I check, for example, the tolerance and I set it a little bit more, a little bit smaller, so checking more or less if every node is the right one, is in the right place. When I run my analysis, it's telling me that I have a problem of instability. This is also useful when you have this kind of problem. So how to check them? We'll go to results, and as you can see, we have all the nodes of my mesh that we can turn on and off using this button. And if we go to select by criteria, in this case, there will be a new element under model, and it's called nodes. This one is not, you don't have this when you search by criteria when you model it, but only when you run the analysis. So in going there, and now I cannot remember anymore my the element number, so bear with me, 52. So we select by criteria, we go to the node, and we type 52 here, and as you can see, it's showing me that I have some instability issues in this node. So I'm going to check it, and as you can see, this node is not in the right place. But the tolerance is less than 1 millimeter. So in this case, it's calculating it. It's not calculating it, while in the case before, it was doing it. So if I go back to my model, and now I can select my element, go closer, and then move it to my node. This maybe is something that can happen also if you are working with really small elements, so maybe elements of 10 millimeters length, or moving them around, working in millimeters, let's say. So in this case, maybe you could set the tolerance smaller, so you can actually work with the structure in a better way. So as you can see, in this case, it's running and is giving me the same result as before. So this is a small case. I've prepared another one that we run through really quickly. So it's this one. In this case, what I've set is are 2 channels, and I try to model some, let's say, rigid element that are bolts between them to connect them. I have my support at the end, and I have a load, as you can see, only in one of the 2 elements. So what is happening in this case if I meshed, I run my analysis, when it's going to mesh it, as you can see, it's telling you null or negative Jacobian. And what can be the problem? If I go to display nodes, as you can see, my structure has a really small element in a really big areas. It's not that big, but it's big for this kind of element I've created. So actually, the best way to sort this out is to model my elements, let's say, with less dividing it in less part, for example, or just creating one element in as a bolt, and then maybe check all the forces around the bolt in another environment, in which we set, for example, only this area, and we check these forces. But in this case, the problem can be sorted also using the tolerance. So if I set a smaller tolerance, just for example this one, now if I run again the mesh, it's going to change it a little bit, but using this kind of tolerance, now I can calculate my structure. So the tolerance can be useful when you have this kind of cases, and maybe it's always useful to check if your model is if you imported it, if it's right, or if you have some nodes somewhere. So in this case, I can see that my displacement are the right one, and as you can see, my structure is behaving as expected. So these were just 2 simple cases that maybe you can have sometimes. So the best thing is always to work with the mesh size that are congruent with the kind of element you are creating. So if you create this kind of bolts really small, or this kind of structure, be aware that more elements you create, more it needs to be meshed, and much is the difference between this kind of mesh size and this one. So these were 2 simple cases. and to present a little bit the mesh tolerance. What do you need that for? Now I'm going to another kind of structure. In this structure, the first thing we are going to see is to set my connection as a semi-rigid. So in this case, the connection has not any release. So we are gonna run I'm going to run my model, and I'm going to see the forces on my structure. From there, what I'm going to do is then checking with another tool the stiffness of my connection, the connection I want to create, and see if it's rigid, semi-rigid, or pinned. In case it's semi-rigid, then we are going to set that kind of let's say moment rotation curve that we have, to see exactly which kind of forces are going to my structure. So for example, now I'm going to forces. I should have already prepared my element. So what I checked is to see my moment in this element and in this one, as are the most solicited ones. So this one is around now I check that, is around 62 kilonewton, and this one, as I said, is around 2.6. So what I did is taken all these forces and go to my to another tool. This is another software that we have, in which I create the same structure. So my columns and beams are the same one with the same orientation angle, etc. I've created a connection, and I've checked the rotational stiffness of this connection. So the connection is fine for the moment and forces that I have, but I'm going to see that is a semi-rigid, is classified as a semi-rigid connection, and I have my my rotational stiffness here indicated. That is the angle of this curve, and what we are going to take is the initial one, so this initial stiffness, and as you can see, this stiffness, I can take, for example, this point, that is the point in which the curve is changing, to then go to the plastic areas, let's say, and it's around let's say 55 kilonewton meter and around 5 milliradians. So I'm going to set this kind of elastic release in my structure, and obviously I need to check that after the calculation my my moment in this element is less than 55 kilonewton per meter, because if it's more, then we are going to the plastic range. So I'm coming back to my structure, to my model, and I'm going to set my elastic release. So sorry, obviously this initial rotational stiffness is around 9.4, let's say, between the two. It's obviously changing between the two elements, but is around the same range, let's say. So I'm going back to my structure. I'm going to my rafters, and what I'm going to do is set an elastic release. I'm setting it as in the end one part of it, that is this area. So I'm going here, And to set it is I need to go in my rotational stiffness and set milliradians and meganewton. So is milliradians. We are talking about milliradians and meganewton meters per radiant. So once I'm back here, what I can change to work with it is to go to my structure sets, modify the units, I validate it, and I click OK. So now I can work with the units I have set, and I'm working with radiant and meganewton per meter on radiant. So I go here, I set my radiant range, and I set my was 9.4 here around. And now I have my elastic release in my element. I'm running the analysis in this case to see if I have exactly, I have less than 55 kilonewton per meter in this element. And then I'm going to show you the difference between the two models I've set and why is, let's say, important. Actually, when you create that and you have a semi-rigid connection in a steel structure, usually you check the deformation, taking into account that, let's say, the worst case. So for the deformation, you are taking the connection as pinned, and for the forces, you are taking the connection as rigid. In this case, we have set exactly our rotational stiffness, and if I'm going to the same moment, I'm going to check that in this element, now is in meganewton. So again, I change and I come back to my units. I'm going to results. I'm going to check this one, and it's 53. So it's less than 55, so it's not reaching the plastic range of this element. So actually, as you can see here now, the forces in my element are less. So my element, if maybe before wasn't really checked, in reality hasn't that kind of forces of a fixed connection, but it has actually this kind of forces going onto the structure. But most important is, if I go to my displacement for the same case, here is 34 kilonewton, 34 millimeters, sorry. While instead, if I come back and now I change my release to be fixed connection, what is happening is that I have more forces on it, but obviously deflection are less. So this is the important part of it. So if you're working with steel structure, you can actually analyze in a deeper way your connection and see exactly how to set this kind of elastic release and how to check your structure in a more deep way. So if I go to displacement and I set the same case, now I cannot remember anymore, but I should have here. Here we go. So as you can see, in this case, it's 26 millimeter. Obviously, because it's stiffener, the connection between the two model, between the two elements. Sorry. So this is how to set elastic releases on the element. The second part is instead to set the soil condition on my structure. That is as well like modeling an elastic support on my structure. So what I'm going to do is I'm going to change my support from fixed to other, and I'm going to release the TZ element. So now it's taking all the rotation and everything, but it's not taking into account the forces, of the FX, the axial forces from the column to my support. So now what I'm going to do is adding an elastic point, and is asking for a stiffness in that direction. What I'm going to do is I'm looking to my footing dimension. In this case, by default, is 1 meter per 1 meter per 0.3. I can set, for example, 0.6 to set, and 1 meter per 1 meter is fine. And what I'm going to set is, instead of imposed, an auto calculation of the elastic stiffness of my foundation. I'm going to definition, and here is asking me for soil layers, within which it then will calculate my elastic stiffness. So I'm going to set insert, and the first layer, for example, is soft clay. I set a thickness, can be 2 meters, and then I set, let's say that then is sand, medium compact, of 5 meters. What is calculating? This layer is starting from the base of my foundation. So it started from the depth of 0.6 meter. So if I change this, it's not going to change my elastic stiffness. When I click OK, it's telling me that this is the stiffness of my structure. And then I'm going to set this support in all my element. Hopefully I did it for all of them. Okay. Now what we are going to check here are the load on my structure. Mainly this load. So as you can see, I've set a different load cases in which the area the most important load is in this area. So this one will have a deformation in the column, and obviously then in all the forces in my structure superior to the one here in the back. So now I'm running my analysis again. And the other thing I want to show you is how to check my slabs, the forces in my slab, so the moment and the shear forces. And we will see it in a few seconds. So now I have calculated my structure. I'm going to check my displacement, for example, for this case. And as you can see, displacement are bigger in this element. So if I'm now selecting my support, I should be able to see them. Let's see. No, I will select my column, showing me the displacement in this direction. Let me check displacement in that direction of my column. Here we go. So we have 14 millimeters for this column, while in this area my deformation is less. So this is more or less the how to set the elastic release. Obviously, forces and moment will be different, also due to this kind of support we have set. So as you can see, there's a different range of forces on my columns. Now I want to check in my slab the forces in my slab. So what I'm going to do is filter my slab. Now select only this one, and I want to set section cut to see exactly the forces in my slab. So if I set a section cut, as you can see, it's difficult for me to select any of these points, and it's difficult to pick it up all the line of this support of this element. So the only one is this one in the middle, for example, and I could check this force, but maybe is not the force, the place that I want to check as well. So now I've set this one, but I want to, for example, to set different kind of section cut for all my length. So how to do that? The best way, I think, is to select my slab in the model area, to select my reference plane. I pick it up and I set it at the level of my slab. And now here I have all my points to set other section cuts. So for example, I can take my lines, I enable the meshing, if not it won't be meshed, and then let's say I can select, for example, this point and set it every, I don't know, every bear with me, every 2 meters in y direction for 4 times. So obviously I can pick all the point of my reference plane, and in this case now I have this kind of lines. Why are they useful? Because obviously now that I'm going to select my structure, turn off my work plane, and showing you, here we go. So what is going to create now is a mesh that still takes into account all the lines I have set. So as I have still my section cut I have set before, but as you can see is actually on a beam, while instead as you can see now I have my reference line with the mesh on them. So actually I could also, for example, select my lines, isolate them. Now I have my lines, I have my section cut, and obviously here we go. I have my section cut, and then I can copy it. I can copy with the copy tool, but I can also copy holding Control button. And now as you can see I have all my section cut already defined. I can turn on my plate if I want to see exactly where they are, but then by selecting one of them I can go to the reference curve. By double clicking on it I can see the moment on the structure. This is M in XX direction, this is M in YY direction, and these are all my cases. Obviously you can also, if you want to check only some of them, you can go to result settings. Here in cases, you can say I want to check it only for the combination. So I select known, I select combinations, and now I've selected only for the combination 35, as 35 we will see are the combination. Forces as well, so known combination, and stresses as well. So I set OK. Number of combination are here, are this one, that are 35. And if I go to result curves, in this case I have only my combinations. That maybe is what I'm looking for. You can check all the forces on that. You can set your legend. You can have a look to the envelope of your moments and just set, for example, the extreme values. And you can do that for each kind of element in each position you want. So if you want more position, you can obviously refine your work plane to set the position where you want. So this is the second example. We have seen the elastic releases. And now in the third example, if I can find it, we are going to see how to set tension and compression only members, tension and compression only supports, and then a couple of tips about meshing and rigid diaphragm. So the first things to we set is, for example, some bracing in this element. This is a load areas, and this is a slab. So in this, on the top roof, we just set a couple of bracing, and we want they work only in tension, for example. So I'm going to set my bracing. I select my floor. I'm going to filter it, turn off the load, turn off this, and now I can actually go to bracing, and I set some L section. So 1, 2, 1, 2. I select them, and I say I want. Sorry about that. There you go. I want they are ties, and I copy them here. So now I have my bracing here, and then what I want to do is also to set compression only support. I'm going to set it here in where is it? In the wind case. I'm going to set it here. So we will see that for the gravitational case it will work in compression. So tension compression only. What you now is already set, sorry. So this is the default the default settings you have, and I'm going to set that is working as a support in that direction. So this is the translation in that direction. I need to set what will do the software is calculating the element in compression only for the direction you will give the stiffness to. So in this case, the translation in that direction, and I'll set it in the middle of these two loads, for example. And it's important to set this stiffness because it will still calculate also the linear case. So explaining better is when you set that a tension compression only member, you need to run a nonlinear analysis case in which it will step by step it will see which kind of element are in tension or compression only. but it's still calculating also the linear case, for which is important that you set a stiffness. If you don't set the stiffness, obviously this element won't have any stiffness and is not able to calculate your structure. So now I have a stiffness in the translation in that direction that will work in both directions in the linear case, but in the non-linear case that I have set for my standard case, 1, 2, 3, 4, we will check the wind forces and the self-weight. It will work only in compression, as well as this element will do. So now I've set my nonlinear case. This one is for later. And I'm going to run my analysis. Okay, so now I have my analysis. I have here I have my nonlinear cases that are the one shown. But if you want to check also the linear cases, you can still go there and select all your linear cases. So now I have my structure. This, as you can see, is the forces for the self-weight. And as you can see, my structure is reacting in this point. And I'll show you, we can check that going here, forces, Fz, and if I set K is 1.1 kilonewton. So this is for case 1. Case 4 is the wind load, and as you will see, there's no reaction. And but if we look at the displacement of this case, so is actually moving that way. And if we select my element in this area, they are going uplift. They are moving 11 millimeter uplift. So this is why it's not working my compression only element. If we go and we check the same for the wind case, the deformation is different and is not actually moving uplift. And we can check the forces in that element. So if it's 1.1 kilonewton. Oh, sorry, wrong case. Forces. Okay. So it's working 22 kilonewton in the other direction. So this is how to set both tension. I haven't shown you the tension compression only member. Sorry. The same is for the bracing. We select our bracing to show only them, the forces on them. So I'm going to look at the forces from the wind load. In this case are working all of them and are working in tension only. And if I change, here I go, non-linear. Yeah, in this case, sorry, as you can see in the linear case, they were working all four, while in these non-linear cases they are working only the one in tension. So if I check, for example, this is just the self-weight, and I have no one working in tension, while, for example, for the wind load, as I said, this one are working in tension. So this is how to set this tension compression only member. And the last thing I'm going to show is a case of a rigid diaphragm. So I'm going to set, in this case, a modal analysis to show you how a rigid diaphragm works. So where I can remove this. and I can keep them. What I'm going to do is selecting my load area and select it as a rigid diaphragm. I don't want the weight on the structure. So now it's set as a rigid diaphragm. I'm going to run this calculation, and it's telling me that there are elements that are causing some issues in my model. So what is going to create, and what I was going to tell you, is that you have, as we have seen also in the first two cases, you have, when you go to the analysis, you can always go to this analysis tool that is the way, that is, let's say, that it's a step between the modeling and the results. In which case, you can still work on your structure in this area. So when you are here, you can change the mesh option, as you can add also constraint and restraint as well. So you can work also on this kind of model. In this case, we are working on this load areas, in this load areas mesh. So as is a rigid diaphragm, is going to mesh it within the structure, but as you can see, is a really weird mesh. And but if we have a look here, what he has created are little load areas, everyone meshed for his independently, and is using a triangulation, an automatic triangulation method. I can go here and set, for example, known, and if I mesh it again, it will be much cleaner. And in this case, maybe my structure is working. So I will run the analysis. Obviously, I have another issue that is due to this point, I think. So let's to check that calculation. I run it 349, and I'm going here. And what it's telling me is that I have this element that are that it cannot handle it because they are in the middle of my slab. So what I can do is still working on it, and maybe set constraint that are going to keep. Sorry, the best way is to filter it. That are going to keep my structure, my point, in the same plane of this other point, as for a rigid diaphragm is useful. If I can select this node and this one, okay. So I need to set for each one of them. Okay, so I need to select it to pick it up really well. So now each one of these point will be the same in the same plane of the other 3 that are already constrained. So if I run my calculation now, it's working. And for example, if I check the movement of my structure, is keeping this element as a rigid diaphragm. So I set only one mode, and as you can see, is working as a rigid diaphragm. What's happening that if you come back to your model and you change your model, you need to set again all these master links, but not if you, for example, you open your model. Now they are still there. So if I change, for example, a couple of sections, maybe the bracing section or column section, I change them to be less. In this case, analysis won't be updated, but if I still open it, my elements will still be there. And what I'm going to do now is I've changed my still changed my element, so I just need to calculate my structure. So the mesh will be the same, but the calculation will be different. But they will keep the same mesh. So if I go to the eigenmodes, now will be different from the one before, but because I have different columns, but it will keep the same mesh properties I have set. So these are the example I wanted to show you. Now, if you want trial of the software, or if you want to have a deeper look in the other webinars, in some example, you can refer to our YouTube channel, that is Advanced Design. I will send you anyway the link to this channel, and you can check also the references to see exactly all the other project that has been done within the software. Other services of Graitec are training, support, consultancies, etc. For all the Autodesk product, most of them. This one, you have some of them. And then obviously for all the Graitec product as well. Thank you for attending, and if you have any question, as I said, please do not hesitate to contact us later on.